Hey everyone, my name's Steve, and today I'm going to show you how to use hot swaps to change your NFT image. And that might sound a little strange because it's Pinata, it's IPFS. Our whole legacy is making sure that content does not change. And while that is still true, there are parts of IPFS that a lot of people wish were more flexible. A lot of people need the flexibility to unlock new creative avenues of ways they could do NFTs. And that's why we built hot swaps. And there's a lot of really cool features in there that add an extra layer of transparency, which we'll get into in just a second. But the basis of this feature is that it is a gateways plugin, which means that it only works if a user has it installed on their gateway. Typically with NFTs, when you are referencing content in a smart contract, you'll typically use either a IPFS link like IPFS://CID, or you might use like a gateway link. So this will only work if the person minting the NFT actually is using that gateway as part of the smart contract and the NFT metadata. And even with this, that's only if they pull the content through that specific gateway. The beauty of IPFS and its interoperability is the ability to take that same CID and feed it through a different gateway and get the original content. So getting into actually how hot swaps works, it's a gateway plugin that is installed on a per gateway level, and it allows you to point one CID to a different CID. So for instance, image of Penny, do a hot swap, and now it's the same CID, it's the same link, but it's pointing to an image of Penny with sunglasses. Now, like I said, Pinata has worked really hard to add extra layers of transparency in this feature. So again, just to remind you, this is only on a per gateway level, so you can always fetch the CID through another gateway or on a peer-to-peer level and get the original content. Additionally, all the Pinata gateways that have the hot swap plugins installed is going to have an actual header in the gateway request that is an E tag, and that's going to have what the updated content is. So if I am fetching CID A and it's giving me CID B, it's going to show CID B in that E tag, so I know exactly what I'm going to get before I even request the content itself. Additionally, Pinata has an SDK method and an API method that allows you to fetch the entire history of a CID, so you can actually see how many times it was swapped and how it was used and have full transparency over the whole process. And I think that's what makes it really special, and I'm really excited to show you guys how this works, so let's go write some code. All right, so the first thing we're going to do is get some things from our Pinata account. If you don't already have an account, you can sign up at app.pinata.cloud. This tutorial does require some paid features, which is the hot swaps feature. Once we have an account open, we can go ahead and get an API key by going to the API keys tab, clicking create new key, and we can give it a name such as hot swap. And we can do admin permissions and then hit generate key. This is going to give you 3 keys, an API key secret, and a JWT. In particular, we want to save that JWT, but save all of it somewhere safe. The next thing we're going to need is our gateway URL. You can get that just by going to gateways and just copying this URL as you see it here. Really simple. Now, the last thing we need to do is actually install the hot swap plugin on the gateway, and it's really easy to do. All you do is go to the marketplace here. We have the hot swaps plugin, just hit install, select our gateway, done, easy as that. So we're in our terminal, and now we're going to go ahead and set up our project. And to do that, we're going to go ahead and make a new directory called hot swaps. Get a CD into that, and then we're going to do npx hard hat init. And we're just going to go ahead and select all the default options with the TypeScript project with VM. Let's go ahead and hit yes, enter for all of these. Once it's done installing all those dependencies, we're going to install just a few more. So first we're going to do npm install pinata web3.env and openzeppelin/contracts. Just go ahead and install all of those. All right, and now we're ready to go ahead and open this project in our text editor of choice. All right, so we're in our text editor within our project, and we're gonna go ahead and set up just a few more things. The first thing we need to do is go ahead and set up an env file. So we can go ahead and go new file, go .env, and in here we're gonna go ahead and put pinata JWT, and this is gonna be that longer JWT API key that we made earlier. Again, do not share this with anyone, this is supposed to be secret. Other thing we're gonna add here is gateway URL, and this is not sensitive, but we do want it just to make it easily accessible, so go ahead and put that in there, and it's just the same format. It'll be like the random name.mypinata.cloud. That should be all you need. The last thing we need is our private key. So when you're deploying NFTs and doing anything with smart contracts, typically you want to create a fresh wallet and put some testnet funds in there, work on testnet first. So for this tutorial, we'll be working with Sepolia, but you can use base Sepolia and all sorts of other networks. And with that wallet that has the testnet funds in there, you want to go ahead and get the private key for that account. And you can usually find that in the wallet settings. You can look how to do that up. Definitely make sure you keep this secret. Make sure you don't have any real money on there, because otherwise you might accidentally leak it and you could lose all of your money. We don't want that. All right, so we're going to go ahead and put account, private key. So go ahead and make sure all those variables are in there and then save your file. Now the next thing we're going to do is set up our hard hat config. This is going to determine some settings and declare some networks so we can deploy the contract to a testnet later. So you want to go ahead and open up the hardhat.config.ts, and I'm just going to go ahead and paste this in from the blog post, which will have linked below. And essentially in here, we're going to have our networks like base Sepolia base and Sepolia, along with some RPC nodes. If you want to use something like Alchemy, you could do that as well. Also have things like our Solidity version and actually engaging our optimizer. All right, with all that set up, now we can go ahead and work on deploying our smart contract for NFT. It's going to be really simple. In here, you'll see our project files. There's going to be the contracts, ignition, and test. We're not going to use test, so we can just go ahead and delete that. And in the contracts, we're going to go ahead and delete this lock.sol. And we're going to go ahead and do a new file. We'll call it penny.sol. And in here, we're going to go ahead and paste just kind of like a nice default contract. Again, this is from the blog post. And this is a pretty simple ERC 721 from the Open Zeppelin Wizard Builder on their website. And we've just enabled our ERC 721, URI stored, pausable, ownable, and burnable. And in here, we've only made just a couple of small tweaks. When you first get this, there's going to be typically an argument in the constructor for the initial owner. We went ahead and took that out and instead replaced that ownable initializer with just message.sender. And essentially what that will do is anyone who deploys this contract will be the owner. Just makes it a little more simplified. And that's pretty much all we need. We can make sure that this is working by running npx hard hat compile. Just make sure everything is working correctly. All right, everything looks good. And now we can go ahead and move on to the actual deployment. So in here, you'll see there's the ignition modules and the lock file. We're just going to go ahead and rename this to penny.ts. And in here, we're going to go ahead and delete some of the stuff that we don't need because our modules looks different. I'm going to call this penny module. Change the word here, penny module. And some of these things are used here to pass parameters into the account, which we don't need. And we're going to change the constant from lock to penny. Going to change which contract. So instead of the lock contract, we're going to do the penny contract. And these are all arguments that are being passed into the contract, which we don't need. Return penny. And finally, update here, penny module. All right, once we have all that set up, we're actually ready to go ahead and deploy our account. So just make sure you have everything set up. Make sure your private key is in the .env file. Should start with 0x. If you have issues saying that's not the right length, you may want to make sure you correct that. And once we were ready, we can go ahead and go to our terminal and we'll do npx hard hat ignition deploy. And then we'll do the path to the ignition module, which is penny.ts, and then -- network, followed by the chain that we want to deploy on. And that's going to use the configuration we did in our hard hat config earlier. So I'm going to do Sepolia, just hit enter, and we'll go ahead and confirm yes. And it's going to probably take, 30 seconds, maybe a little bit less. So just be patient while it deploys. Depending on what chain you're on, it might be a little faster or a little slower. All right, so once our contract is deployed, you will have a contract address right here. Go ahead and copy that down, keep it somewhere safe. We're going to use it in just a little bit. Okay, so our smart contract is deployed, but before we can mint NFTs, we actually have to prep them first, because an NFT is really just a token that has a token URI, which is the long string that references information off chain, everything you need to know about the NFT, such as the name, description, image, etc. And of course, we'll be storing that on IPFS, but before we can even do that, we want to go ahead and upload our image to IPFS first, and then reference it in the smart contract metadata. But before we upload, we're going to go ahead and set up a little bit of a config file that we can use for both our Pinata SDK as well as VM when we're minting the NFTs. So to do that, we're going to go ahead and make a new folder called utils, And in here, we're going to make a file called config.ts. So in here, let's go ahead and start building some stuff out and importing some things. The first thing we're going to do is do import Pinata SDK from Pinata-web3. Then we're going to import some things from VM. That's going to include import, create wallet client, create public client, and HTTP, which is a transport from VM. We'll also do import private key to account. Gotta make sure we spell it right. That's from VM/accounts. And we also want to import a chain. So we'll do import Sepolia from VM/chains. Oh, and let's change this to accounts. There we go. Got everything imported. So now we can start declaring some stuff. The first thing we'll do is export our Pinata SDK. So we'll do export const Pinata equals new Pinata SDK. And in here, we're going to put a couple of things. We're going to do the Pinata JWT. We'll just do process.env, and we'll do Pinata JWT. And we'll do the Pinata gateway, and we'll do process.env gateway URL. There we go. And one thing I also just remembered, we want to go ahead and import .env/config. And then we'll just make sure all of our environment variables are being processed correctly. And then we need to go ahead and also do our wallet clients. So we'll do export const public client equals create public client. And we'll do chain is going to be Sepolia. Transport HTTP. There we go. There we go. And we'll do the same thing for the wallet client. Export const wallet client equals create wallet client chain Sepolia and transport HTTP. And finally, we're going to do our account. So that's going to be export const account. And this is going to be our private key. So private key to account. We're going to do a process.env would be account private key. And we'll do that as a hex string, just so it doesn't make any errors in our TypeScript. Save all of that. And now that we have our config set up, we can actually start on our script to upload our files. We're going to go ahead and create a new folder called scripts. And inside that folder, we're going to make a new file called upload.ts. So in this file, we're going to go ahead and import that Pinata config that we just made. So Pinata from util/config. And we're also going to import fs from node fs. There we go. And we're just going to do an invoked function. So if we're only going to use it once, we're going to do async function upload. And in here, we're going to go ahead and import our file. Since this is a local file, we need to turn it into a file object. We're going to turn it into a buffer, and then a blob, and then a file, which is pretty simple actually. We'll just do const buffer equals fs.read file sync. And we're going to go ahead and pass in the path, which is just any.png. And then we're going to do const blob equals new blob. And in here we just pass in that buffer. And then we do const file equals new file. Just pass in the blob. And we're going to do the file name, which is penny.png. And that is going to be a type of image/png. You guessed it. There we go. And now we can finally upload. We're going to do const, and we're going to go ahead and deconstruct the return object. So it's going to be ipfs hash equals await pinata.upload, and then we'll do file, just pass in the file, and then just console log that ipfs hash. There we go. Got everything in. So we'll see if it works. Just go down here and do npx hard hat run scripts upload.ts. And there we go. We have our CID right here. This is going to be our image CID. Save that for right now. We're going to go to the next bit. Okay, so to actually mint our NFT, I went ahead and made a new file called mint.ts inside of our scripts folder. And we're going to import a few things. So we're going to import the Pinata SDK instance that we declared earlier. We're also going to import our public client, wallet client, and account from our config. Now, something else that we need to import that was actually created when we deployed our smart contract is the ABI file. This is what allows us to communicate with our smart contract using a different language. So we're going to do import ABI, and this is typically going to be in a artifacts folder. So we're going to do -- we'll do artifacts, and then if we go under contracts, you should see the name of our contract. It's another folder, and then we should see a penny.json. There we go. If we go to that file, you can see here, this is the ABI object that we are referencing and pulling from. It has all the information about that smart contract. And of course, lastly, we're going to import the .env/config because we'll need that. And now we're going to do another invoked function, which is going to be our mint function. So we're going to do async function mint. There we go. And in here, we're going to do two things. First, we need to go ahead and create that metadata file, the token URI that we're going to use is going to have all the information about our NFT. And then we're going to actually pass that into minting the NFT. So we're going to do something similar. We're going to do const IPFS hash, but we're going to call it URI. That's going to be equals await pinata.upload. And since we're not going to be using the local file, we can actually just do a JSON file and do it directly from the SDK, which is really handy. So in here, we're going to give the name of the NFT. We'll just call it penny. Do description. Nice penny NFT. And we'll do image. Now this is the important part, because in order for our hot swap to work on this NFT image, we have to use the gateway as the image link. So we're going to do HTTPS, and in here we're going to do $brackets and do process.env and do gateway URL. And then we're going to do IPFS, and then this is where we're going to pass in that image CID that we had earlier. All right, so we have our image link in there, and we'll add one more thing. We'll do the external URL, and we'll just do HTTPS pinata.cloud. Excellent. So we have our IPFS URI hash that we're going to use in our smart contract. And so now we can actually do the mint function. Now to do this with VM, we're first going to simulate the transaction to make sure everything's working properly, and then actually call the transaction with our private key using that wallet client. So to do that, we're going to do const, and we'll do request equals await public client dot simulate contract. And we're going to pass a whole bunch of things in here. First thing to do is going to do the account, and that's what we imported from our config. We're going to do address, and this is going to be that smart contract address that you had earlier. Okay, we're going to do ABI, and then the function name. This is going to be the function name that we're calling, which in this smart contract was safe mint. And then last we have args. This is arguments that we're passing into the function. So the first thing it's going to pass in is our wallet address, or who the NFT is being sent to. Go ahead and put that in there. And the next thing is actually going to be that token URI that we talked about earlier. So for that, we're going to do a backtick. So we're going to do IPFS : / and then we're going to do $bracket URI. And that's going to put in that IPFS hash that we just did. So that we've simulated the contract, we can actually call the transaction. So to do that, we're going to do const tx equals await wallet client dot write contract, and we'll just pass that request in, and we'll just console log that tx. All right, so it's all set to go. Let's go ahead and mint our NFT. We'll do that by doing npx hard hat run scripts /mint swap.ts. And it might take a few seconds because it's going to initiate that transaction and do the upload all at once. And there we go, we have our transaction hash. All right, so we minted that NFT and you can actually go view it at testnets.opensea.io/assets/sepolia/ the contract address, and then following one more slash with 0, which is the first token ID. You can see here we have our penny, very, very nice. Have the contract all set up to go. So remember what this penny looks like first. So in order to actually change the image under an NFT, we have to swap it out for a new file that we have to upload to IPFS on our account as well. And so we're going to do that by uploading a new file. We're going to call it newpenny.png that I have saved in my project folder. Update that, and then we'll just run that same upload script, hard hat, run scripts /upload.ts. Gonna take just a second. And there we go, we have a totally different CID than the one we had before. So go ahead and save that CID. Now I have a brand new file open called swap.ts that's under our scripts as well. We're going to import the Pinata SDK config from there. Call another function. We'll go async function swap. There we go. And in here, it's actually going to be really simple. All we have to do is just do const swap equals await Pinata, await Pinata dot gateways dot swap CID. And in here, we're going to pass in two things. First, we're going to pass in the CID, which is the original CID that we had when we first uploaded. So let's put that in here. There we go. And then we're also going to call the swap CID. This is going to be the image that we just uploaded that we want to swap the content out for. And so we're going to put that in there. I'm getting a little ale here, so I'll just call this swap CID. And then we can go ahead and console log it out. Console.log swap CID. And now let's go ahead and run an npx hard hat run scripts /swap.ts. And there we go. You can see that we've updated this map CID and it has created at. We also have a method if we wanted to use, we could actually list out the entire history of the swap for that CID and see how it's changed. And now we can go back to OpenSea and see the updated image. All right, and here is our brand new penny looking really, really nice. Cool sunglasses. Something to keep aware of too is that usually marketplaces like OpenSea are going to cache images pretty heavily. And so sometimes you have to click here and click refresh metadata. And, you know, could take a while for things to reflect, but it is actually updating the content of that CID. If you visit the gateway, it's going to show one CID, but it's actually going to point to the new CID. And so you can imagine all sorts of interesting use cases for this type of NFT where you can update certain things, but still have a record of the content and accessing the original content on IPFS, an immutable peer-to-peer network. Well, that wraps it up for our hot swap tutorial. I hope y'all enjoyed it. And as you can probably imagine now, there's so many capabilities we haven't even unlocked with this whole feature. It honestly unlocks the ability to have a database without a database. And we'll be making more content like that soon. So if that's something you enjoy, be sure to like and subscribe, leave a comment if you have any questions. And of course, till next time, happy pitting.